In this live session, I will teach you the concept. Prove root 2 is a rational number. Okay, I will start. I will write the question over here. Prove that root 2 is a rational number. Proof. Okay. First, we have to do what we have to do. See, first, what they are telling, prove root 2 is rational, right? First, we have to assume opposite to that. Opposite to irrational number is what? Rational number. Okay. So we will assume root 2 as rational number. See, we have to prove root 2 is irrational. Irrational number. For proving, first step is we have to assume root 2 as opposite to this. Opposite or in reverse way. So opposite or in reverse way means instead of irrational, we have to assume root 2 as rational number in the first step. So starting from that, we have to proceed to finally to prove root 2 as irrational. So first step, we have to assume this root 2. We have to write a sentence like assume to the contrary, that root 2 is rational. So contrary means it's like opposite in reverse. Okay, opposite to this irrational, we are assuming root 2 as rational. That is the first step. So we are assuming to the contrary that root 2 is rational. So this is the first step. Okay. When root 2 is irrational, that means root 2 can be written as R by S. Okay. R by S, where R and S are integers. I'll write it here. R and S are integers and this S is not equal to 0. Okay. Why I took root 2 is equal to R by S? Because we are assuming root 2 is rational. So rational number means a rational number. I will write number also. Okay. So a rational number is in the form of R by S. Instead of R by S, we can take P by Q also. But here I will take R by S only. Any variables you can take. A rational number is in the form of R by S. This is in general. R and S are integers. So integers means you know, right? Minus 4, minus 3, minus 2, 0, plus 1, plus 2. So etc. etc. So till infinity. All positive numbers, negative numbers, and 0. Those are integers. So rational number means rational number is in the form of R by S, and these two are integers, and this S should not be equal to 0. So this I have written because rational number. So this is the definition for rational number. Since we assumed root 2 is rational number, so I have written root 2 is equal to R by S. We can write like that. Next, suppose if R and S are have common factors, I will show an example. Common factor means, so for example, in place of R, I will take 5, sorry, 10. No? In place of S, I will take 20. Common factor means 10 can be written as 5 into 2, 20 can be written as 5 into 4. Correct? And further, this 4 can be written as 2 into 2. Correct? Common factors other than 1. See here, 5 is common. Here also 5 is a common. Okay. So the common factors are other than 1. I mean, common factor means 1 should not be there. 1 should not be there. Other than 1, any number. 5, here also, this 5 is not 1, right? Not 1. So 5 is not 1. So 5 is common. Here also 5, here also 5. So that is the meaning of common factor other than 1. Okay. So now we are proving this theorem in general. In general, I mean we are not taking any numbers for R and S. So we are taking variables. So now suppose I'll write the sentence, you'll understand. Suppose this R and S. This R and S have common factor other than 1. Then we divide. Then we divide when divided by the common factor. Common factor to get root 2 is equal to A by B. So A and B are co-prime. Co-prime. So remember, so common factor, I just explained how is that. For example, this R and S have common factor like this. Like this, here also 5, here also 5, other than 1. So that's what I mentioned. Other than 1. So 5 is not 1. Okay. Suppose, so this and this have common factor. Then if you divide this R and S by that common factor like this is just example, but I am speaking in general. So if R and S have common factor like this, and if you divide this R and S by that common factor, then we will get, instead of R by S, you can write A by B. So we got A by B when we divided this R and S by the common factor other than 1. It should not be 1, any other number. Okay, got it right? When this R and S are divided by the common factors, then we will get A by B. Then we can write root 2 is equal to A by B. And this A and B are co-prime. Co-prime means common factor is only 1. I will show that. For example, let's see. Okay, see, 2 and 3, these are common, sorry, these are co-prime numbers. Because so 2 can be written as 2 into 1, 3 can be written as 3 into 1. Okay, here you can see in both the common factor is 1. Correct? When common factor is 1, then 2 and 3 are co-prime. Okay, so co-prime numbers are the numbers which have common factor 1. Okay, so those are co-prime numbers. So now next step. Okay, I will just erase this above part. This part I will just rub. See any previous content. If you want to see, you can just move the video backward. Okay. Okay. So we got till here. Now see, I will write this implies. This implies means root 2 is equal to a by b means a by b. Now see, you can move this b to this side. When you b move this side, then what happens? This root 2 will be here only, and b comes here. So then it root 2 into b. Root 2 b is equal to this a. Okay. So that is implies. This is implies not equal. So instead of root 2b, we can just interchange these two. So instead of root 2b, I can write b root 2 is equal to a. So both are same, no problem. Root 2b, or if I interchange b and root 2, I can write b root 2 is equal to a. So no problem. Now what I will do, I will square on both sides. I will write here on squaring on both sides. If you square on both sides, what you will get? First you write this b root 2, you have to square, okay, is equal to, then a you write as it is, then square. Next, that is implies. Now see, this square, because b into root 2, here in between b and root 2, there is into is there. So square can be applied for separately and for this also. Now b, this square, next root 2, this root 2, this square. This is equal to a square as it is. Now that is implies. So in the next step, b square you write as it is. These two, this square root cancels. What is left? 2. Okay, na? So into 2 is equal to a square. Now that is implies b, because of into, we can interchange this and this, b square and 2. I mean, first I'll write 2, then this b square. So you can write like that, no problem. So that is equal to a square. Now from this, what we can say, what we can understand is 2 divides a square. So remember, this is 2b square, right? Between 2b square into is there. 2b square or 2 into b square, both are same. So this implies, because of into between 2 and b square, so that is implies this 2 divides this a square. 2 divides a square. So this 2 divides this a square. So that is implies again, since 2 divides a square is nothing but a into a, correct? A into a. So because of a into a, so when 2 divides a square, this 2 divides this a. That is the meaning. A square is a into a. Because of into between a and a, this 2 divides a also. So based on this, so 2 divides a, because of this we can write like this. So A is equal to 2C we can write. This A we can write here, this 2 we will write here, and this C is some integer. You have to write what is this C. C is some integer. C is some integer. That's all. Okay. Except this, you can write like this. C is some integer. You have to mention that also. This I will call this as equation 1. Now what I will do, I will substitute this A is equal to 2C into this equation. I have to write the sentence also. Substitute A is equal to 2C into this equation 1. Okay. Yeah. I will rub this. So any previous content, if you want to see, you can just move the video backward. Okay. So first, so 2b square I will write as it is equal to, so in place of A I will substitute 2c. So 2c bracket and this square. So that implies, so write this 2b square is equal to 2c. It's like 2 into c. Because of into between 2 and c, you can take square separately for this 2. So first write this 2, then square, next into c and this square. Now next step, write this 2b square as is equal to 2b square is equal to 2 square can be written as 4. 2 square means 2 into 2, 2 4. This c square will be as it is. Now I will write divide both sides on dividing both sides. So we want b square, we don't want 2. So what I will do, we will divide both sides by 2. On dividing both, no. First I will write divide both sides so you will understand. Divide both sides by 2. So what you will get? First write this 2b square as it is divided by 2 is equal to 4c square. This 4c square as it is divided by 2. I divided this 2b square by 2 and this 4c square by 2. That is the meaning of divide both sides by 2. Now this 2 cancels. Now 2 ones are 2 twos are. So that is implies. So what is left? B square is equal to 2cc square. Okay. So till now you understood, right? Yeah. Now I will just erase this part. Yeah. Please move the video backward if you want to see any previous content. Okay. So we got till here. P square is equal to 2c square. Now see, 2c square is nothing but 2 into c square, correct? 2 into c square, because of into between 2 and c square. So this, what does it mean? 2 divides b square. I will write it here. That is implies. Which implies? This equation implies 2 divides this b square. Okay? That is the meaning of this. This 2 I have taken here, this b square. Now that is implies, so b square can be written as b into b, correct? B into B is B square. B, when I say B into B, there is a into, right, between B and B. So because of that, so these two divides, since 2 divides B square, this 2 divides this B also. 2 divides B. So that is the meaning. Now, 2 divides B means what? Previously I have written, right, root 2 is equal to A by B, because we assumed root 2 as rational number, so we got A by B. I showed that. I've already explained. Okay. So now I am telling 2 divides B. So what does it mean? We have seen 2 divides A also, 2 divides B also. That means what? 2 is dividing both A and B, both this A and B. That means 2 is a factor, common factor. So when 2 divides A and 2 divides B, that means this A and B at least have 2 as the common factor. So I will write that. So that is implies A and B, this A and B at least have at least 2 as common factor. 2 as common factor. At least means minimum. If there are no other common factors, at least there should be there should be one common factor. That one common factor is 2. Why? Because we have seen 2 divides B and we have seen 2 divides A also. When 2 divides A and B, that means there should be at least one common factor, that is 2, because 2 is dividing both A and B. So till now you got it right. Now what does it mean? A and B at least 2 as common factor means, so does mean this contradicts, it says opposes. First I will write the sentence, then I will explain. So this statement contradicts, this contradicts A and B have no common factor other than 1. Contradicts means speaking in reverse direction, opposite direction, speaking in opposite way. So in the beginning I said A and B are co-prime, correct? Co-prime means A and B have common factor what? Only 1. So A and B common factor should be 1 only. So since we assumed root 2 is rational number, and when root 2 is rational number, then root 2 can be written as A by B, and A by B have common factor only 1, because A and B are co-primes, because we assumed root 2 as rational number. So in the beginning I said, since we assumed root 2 as rational number, so when we assume root 2 as rational number, that means A and B have only one common factor, that is 1. But here what we got? A and B have at least 2 as common factor. Okay? When root 2 is rational, we assume root 2 is rational, common factor should be 1 only. But here we got common factor 2. That means what? what we assumed in the beginning, A and B have only common factor, that becomes wrong. So this is telling in reverse way, right? So in the beginning we said A and B have no common factor other than 1. That means only one common factor, that is 1. In the beginning we said like that because root 2 is assumed as rational number. But this statement is saying in reverse direction. Reverse means instead of 1, it is saying 2 as common factor. So, so this statement is saying reverse way. Reverse way means that is contradicts. Contradict means saying in reverse way. Okay. When we assume root 2 as rational, common factor should be 1. But this is saying in reverse way. This is saying in reverse way. Why this is saying in reverse way? So since this is saying in reverse way, that means in the beginning whatever you assumed, that assumption is wrong. So this is, I will write here statement. This is because of incorrect assumption. Incorrect assumption. Incorrect means wrong assumption. We assumed root 2 as rational number, so because of that A and B should have common factor only 1. But we got 2 as common factor. So this is saying in reverse way. So why we got this in reverse direction, wrong direction means because in the beginning we assumed root 2 as rational number as wrong. So this is because of incorrect assumption as root 2 is rational. Okay. So there, so since we got this wrong statement, that means this statement is in reverse way. Because of this reverse statement, so it is understood that the assumption whatever you assumed in the beginning, like root 2 is rational, that is wrong. So when root 2 is rational, assumption is wrong. That means what? Root 2 is irrational. So root 2 is irrational. Okay. So we proved that root 2 is irrational. This is final answer. What was the question or theorem? Prove that root 2 is irrational number. So we proved it. At the final stage, in the last step, we proved that root 2 is irrational number. See, just I will just remind you, the question was prove root 2 as irrational number. In the beginning, in the first step, we assumed that we assumed in the reverse way. Instead of irrational, we assumed rational. Since we assumed rational, we got the wrong statement. So finally, it is proved that our assumption is wrong. So root 2 is not irrational. Root 2 is root 2 is not rational. Root 2 is irrational. Okay, proved that. Question is prove root 2 is irrational. So we proved that root 2 is irrational. So that's all. So that is the answer. This is the proof. Okay. Yeah, thank you. Anything if you want to say related to this teaching and concept, okay, please mention in the comment. I will follow that. Yeah, thank you and subscribe.